Hello everyone. Today's topic is parathyroid and calcitonin hormone. My name is Shiraz Mumtaz, and we're going to discuss about the parathyroid and calcitonin. The objective is what is parathyroid hormone, what is the calcitonin hormone, and what is the hyperparathyroidism. Okay, so the parathyroid hormone is used for the calcium homeostasis mainly, which means that if it is calcium is decreased, the parathyroid hormone is trying to increase it, and if parathyroid is calcium is decreased, so if calcium is increased, parathyroid hormone is going to be decreasing its secretion and not to increase the reabsorption as such. Okay. So parathyroid hormone, where is secreted by? It is secreted by a principal cells within the parathyroid from the parathyroid gland. Where the parathyroid gland is located, they are located right in the back of the thyroid hormone, which is in the back of which is in the front of our neck. As I discussed earlier, that increased parathyroid hormone increases the calcium and decreases the phosphate ion. Okay, as I discussed earlier, it is a major role in the calcium homeostasis. Okay. Now the calcitonin, on the other hand, it is secreted by a parafollicular C cells or uh, C cells by itself within the thyroid gland. Thyroid gland is secrete the thyroid hormone, but within the thyroid gland we have a cells called C cells that is actually produces a calcitonin, and calcitonin causes the decrease in the calcium ion, but it has a very minor role. The major role, as we said earlier, it is going to be a parathyroid hormone. Okay. So how does it do it? We can go into different ways. That what are the effect on the bone of the calcitonin and parathyroid? We can check it in the side by side. So what is it with the calcium? Calcium, it inhibits the osteoclastic activity. Osteoclastic activity, which is called the canceling the cell, which is the clastic canceling. So it inhibits it. Okay. On parathyroid, on the other hand, it is going to stimulate the osteoclastic activity, canceling bone resorption. So what ultimately is going to do is whenever we're going to see a decrease in the calcium from our diet, from our in our blood. So what parathyroid is going to do is take it from anywhere, either from the digestive tract, either from the kidney, either from the bone. They were gonna get it from there. They were gonna get it from it and put in the blood. They were gonna get it from the bone and put in the blood to keep the blood calcium level close to the normal. So which means that that we need to have a proper intake of the calcium from either from milk or having vitamin D, so we have the better absorption of the calcium as such. Okay. All right, moving forward. So how is it going to do effect in the kidney? Calcium, sorry, calcitonin is going to increase the elimination of the calcium, okay, and then phosphate as well. On the other hand, the parathyroid is going to increase the absorption of the calcium and elimination of the phosphate, okay, and it stimulates the calcitriol production, which ultimately increasing the formation of the vitamin D, okay, later on. All right. On the effect of the GI, there is no effect of the calcitonin on the GI, gastrointestinal system. On the other hand, parathyroid is going to do several things in the GI. It stimulates the calcium and phosphate absorption by helping the vitamin D3 okay, activation. And then the activated vitamin D stimulate the phosphate absorption and then to promote the precipitation. Calcitriol okay, which is form of the vitamin D3, okay, which is the synthesis from the activated vitamin D3. The activated vitamin 3 stimulates the calcium absorption from the intestine, so that's what it does. Okay. So right here, as you can see, this is a very what we call a small picture of, as you can see, the low blood glucose. As I said earlier, that whenever you're gonna have low blood calcium, okay, so low blood calcium, what it's going to do is increasing the secretion of the parathyroid. As I said, like this is a thyroid gland. These are the four parathyroid gland on the each side of the thyroid gland, and now this is in the back of the thyroid gland, which is in our neck. So right here, what is going to do increase osteoclastic activity, which means that it is going to release the calcium from the bone and put it into the blood, okay, as I said earlier. And the parathyroid hormone ultimately is going to increase the calcium reabsorption from the kidney tubule, and then it is call the activation of the vitamin D, like by the kidney, and then it is going to, as a function, increase the reabsorption of the increase the reabsorption of the calcium from the intestine, and then ultimately causing increasing in the what is it called, a calcium in the blood, calcium level in the blood. So at the same time, you can see the reverse of it. If somebody have the hypercalcemia, the parathyroid is going to decrease. Ultimately, is going to decreasing the osteoclastic activity, which means decreasing the bone resorption and increasing the bone density, and then increasing the decreasing the bone calcium reabsorption. Okay, and then decreasing the vitamin D activation by the kidney, and then decreasing the resorption if we have the what is called hypercalcemia. So that's what it does. Okay. So the next thing what we are going to see is the what is the hyperparathyroidism. Okay. I'll discuss that it is causing the increase or excess of the what we call the parathyroid hormone. Okay, parathyroid hormone increase causing the hypercalcemia. Okay, and then hypophosphatemia, as we discussed earlier, that it is going to be what is it called, decreasing the phosphate level. Okay. So the symptoms include symptom can include nothing. Sometimes it can go asymptomatic for years, that you may not see it if it is not that much of increase of the calcium, which is 12 milligram per deciliter. Okay. So if we have a symptom, we can have the muscle weakness, okay, then the decrease in the alertness, because it can cause the what is called neurological symptoms. Poor memory, yes, it can do that. Okay, and then reduced bone mass, as we discussed it earlier, that is because of the osteoclastic activity, osteoclastic canceling the bone cell, increasing the bone resorption, and then right here ultimately is the kidney stones. And sometimes it is possible, there's people have many kidney stones, in every month or every 6 months, and then they were gonna go for oh, let's check their parathyroid hormone, and then they ultimately found hey, there is an increase of the parathyroid um, hormone. Okay, and there are different causes of it, so let's go over the causes. Okay, so there are a few causes, that the familiar okay, this is what they call a genetic condition, which is the familial hyperparathyroidism, and then they what they call the parathyroid hyperparathyroidism, and is caused by the mutation, germline mutation of the CASR, which is ultimately the calcium sensing receptors, and the partner protein. There are other protein as well. The most common is the CASR, which is the calcium sensing receptors. So the FH8 is an what we call the autosomal dominant, which means that it needs only one gene to express. Okay, and that causes the lifelong elevation of the calcium, increase of the calcium concentration within the blood, within the serum. As I said earlier, most of the individuals have no or very minimal symptoms, and there are three genes are discovered from FHH1 to FHH2 and FHH3. Okay, and it can be caused by the heterozygous, not the homozygous, because it is the autosomal dominant. So loss of the function of the calcium sensing receptors gene, okay, which we're gonna come in next, okay. So the potential role of the altered parathyroid, okay, the calcium sensing receptors expression in the pathogenesis of the parathyroid, primary hyperparathyroidism. So what usually it's done is that the mutation of the parathyroid oncogene and then the tumor suppressor gene. Okay, so when there's a mutation, when there's a tumor suppressor gene, what it's going to do is it increasing the epigenetic modification of the calcium associated sensory receptors promoter gene. Okay, it is going to decreasing the gene expression of the calcium what is it called sensory receptors gene expression. Okay, then ultimately is causing the decreasing the cell surface, the cell surface, okay, the calcium surface receptors, the homodimers. Okay, and what is going to do is reduce the what is it called a parathyroid calcium sensing receptor gene that may face the impaired signal of the transduction, and then ultimately what is going to do is increasing of the parathyroid secretion and parathyroid proliferation. Okay, so which means that if there is no signal transduction, which means there is no inhibition. Okay, so it is going to when there is a decrease in the inhibition, it is going to increase in the expression of the parathyroid hormone secretion, and then increasing the what they call the proliferation as well. And then when the parathyroid is increased, is going to increase the now what is called the calcium absorption. Okay, so the what is the role of the what is it called the CSR GABA GM GABA B1 R heterodimers? Okay, so um, so what is going to do is what is it called? Okay, so right here, as we have a the CASR GA-GABA1 heterodimers are they are these actually meant for to inhibit the signaling from the what do you call a CASR. So when this is what you call decreased, and this is causing the ultimately not be able to inhibit what they call the decreasing in the signal of the CSR, signal transduction, and whenever you're gonna see a what do you call, it has to be up, okay, to protect the increased secretion of the parathyroid. When this is decreased, it is causing the increase, ultimately causing the increase of the parathyroid secretion and parathyroid proliferation, and that ultimately causing the hyperparathyroidism, causing the increase of the what we call osteoclastic activity, bone destruction, and nephrolithiasis, which is the stone formation in the kidney, and causing the mental alertness, and also other cardiac issues as well. So that is going to be treated by the parathyroidectomy, and then causing the what's it called decreasing of the thyroid hormone secretion. Thank you very much.